Hello, this is Benign and welcome to the next video, which actually will be the beginning of series of 2 videos. Unfortunately, after recording the tutorial, I realized that it is a bit too long and I had to split it in 2 parts so it will be easier for you to watch. So, we will be making this Ferris wheel. Some time ago, I created this animation and posted it in my Instagram. And actually, it was picked up by Porsche, who wrote me a message and they posted it on their TikTok. But unfortunately, I checked today and it's no longer there. But I have some screenshots if you don't believe me, so you can check on my Instagram. And I created this 2 and something years ago. And this was one of the first procedural animations set up with the geometry nodes that I did. And I really enjoyed the process. So I wanted to explain how I did it. But this time we'll be using slightly different reference, something like this. You will see me during the video pointing into some parts of this reference. And the end result will be looking something like this. Yeah. And what's cool, you might look at it and say, well, what's so special about it? I can model and animate it quite quickly with the traditional tools. Yes, you can, but it will be not so procedural. You will not be able to change the parameters of this thing procedurally in the size, the dimension. You can also change the number of the cards. I didn't expose the parameter here, but it's very easy to do. So, and what's also interesting is that we will be not using some complex vector math or some complicated stuff like the last time. We'll be using very simple nodes, and the point of this is to illustrate how with very simple knowledge, very simple nodes, you can create something very, very powerful. And well, in the Houdini world, people do this all the time. Like if you Google or search on YouTube, you will see a lot of people doing some procedural houses and stuff like that. And I want to illustrate same principles, but this time in the Blender and geometry nodes. So let's begin. So we are starting as usual with empty scene with the screencast case enabled, and I will select everything and delete it. Let's go to geometry nodes and don't forget to enable screencast keys here as well. And let's create some mesh. We can do cube and new geometry nodes modifier. So we will cut the connection and we will create mesh circle. Let's see it with maybe 16 vertices. And the radius we will plug as a group input so we can control it later. Let's set it to maybe 20 meters. And we need to rotate it so it's vertical. Let's do it. Transform geometry. Let's rotate it by 90 degrees. And we will do another transform to do the animation. And for animation, we will use combine XYZ, plug it into rotation, and let's see which axis, not this one, this one. And we will plug some value. And for the value, we will use expression frame, which will give us frame number divided by maybe 20. Let's play. And our Ferris wheel is rotating. So this will be the base of our Ferris wheel. Let's make some room. Let's do some reroute. And we're gonna go vertical at this line because we will use this input as input in many steps that we need to work on. Sorry, it's a bit hot in where I am, so I'm a bit slow. So we're gonna start with the basis of rotating cards. We need to instance on this point some lines that will be the beams that support the cards. So let's do that. We will use mesh line, and then we will do instance on points. And we will use this rotating wheelbase as an input for the instance points. And let's plug our mesh line to see what we get into instances input. Right now they are going the wrong direction, so let's fix that. We need to go them maybe along y-axis, and we need not to use offset but endpoints. Let's try first y-axis, probably. Yes. And basically at this point we are defining the width of our Ferris wheel. So it would be nice to control it also as an input. So we can duplicate this guy. And we will use combine XYZ. And let's plug Y input. And we will call it width. So this will be the width of our Ferris wheel. Let's put maybe 2 meters for now here. And we can plug it as a start location. And this we can just scale to invert it for the end location. And now we can control the width of the Ferris wheel. Well, not technically, it's a bit incorrect because this is the half width, but we can pretend that it is good enough for us. And what's cool is that since our input geometry is animated, we can play it and it will keep rotating. Maybe it's a bit too fast, you know. Let's change it here. Divided by 10. Actually, you can also play with some parameters as input to control the speed, but for these tutorials we don't really need it. Oh, actually it's the other way around. We need to divide by a bigger number to make it slower. So now we have it. I'm gonna leave it at this for now, because we also need to instance the cart itself, but we're gonna come to this a bit later. So now we need to create outlines, and I'm thinking of making it a bit wider. The outlines of the Ferris wheel. So let's take this, create reroute. And all we need to do, if we view this, we need to offset it left and right, basically copy it to match the width of the Ferris wheel. So we can just do that actually, and this one we can do Control H, and to hide all the unused parameters. So this will be our width input. So let's copy it here, and we will use transform geometry. And actually we can also copy this guy and scale as well, actually. So let's plug it into the Y. This goes into the scaling, and this goes into translation. So it moves this way. And then we will take this guy, copy it, use same input, and use the inverted transform to move it the other way. And now we can join these two guys, and we have our base. And what we can do is create reroute and start merging this with the join geometry. So this guy goes here, this guy goes here. And let's preview it. Okay, we have our base. So if we look at our reference, we can safely say that we are done with these guys, the beams that support the cards, and we also have these circles, the outlines. And since we are dealing with the circles, we can go ahead and create these guys. And we can create them by just transforming the geometry. So let's just do that. We can take this geometry, do transform geometry, and just scale it. Scale it by X and Z axes. And let's plug this for so we can see the preview. And we can use combine XYZ. Plug it Let's put 1 everywhere, and let's use some value to control the scale of these smaller circles. Yes, and it works. Let's keep it like this for now. We can adjust it later. So the next step would be these diagonal beams that support the whole structure. And let's make some room. Let's do some housekeeping. So we can keep using our vertical line. Let's do new reroute. And let's talk how we're gonna create them. I'm gonna do some annotation. What we can do is instance some lines into each point and then rotate them that they're all facing the center and scale them so they are the appropriate width. And how we're gonna do that? Let's see. I'm gonna try to erase it. Let's do the easiest way. So first we need some lines. Let's do mesh line. We don't need so many points, so let's use 2. And endpoints. The scale is important that the width of the line is 1 because we will scale it. And we can do instance on points. The points will be our base structure. And we can plug it so we can see the result. Let's plug it into our mainstream and let's use this as instance. So we have these lines. The second thing, we need to rotate them. And in order to rotate them, we need to create a vector between the origin. Let's put cursor back to the origin. We need to create vector between origin and our instance point. And we can do that by subtracting. Yeah, now I know how to delete stuff. We can subtract the position. Basically, we don't need to subtract because the position of this instance point is basically a vector coming from origin to this point. So all we can do to rotate this is align rotation to vector. And for the vector, we will use z because our line is pointing z. And for the, for the vector, we will use just the position. Position. And our line is facing the z-axis, so we use z-axis. And we can plug it into rotation. And nothing happens because we have to plug the vector. And as you can see, it works, but it's just going the opposite direction, which is fine. Can we do vector -1? No, it doesn't work like this, but we can put the line going into the negative z, basically. And the second thing is the scale. And scale is basically the length of the position vector. So we can say, we can measure the length of the vector, put the position here and plug it into scale. And there we have it. And it will keep rotating. But it's right now positioned in the center of the Ferris wheel and we need it on the outside. So we can do the same trick as we did here. We can just copy all these nodes. Shift D. And we will take this guy and oops, plug it here and plug it here. And this is our base of our Ferris wheel. So the next step would be to create some structure lines. Unfortunately, they are not present on this reference, but I've got this idea from looking at some other references. We want to create some diagonals going from this angle to this point to this point. So this kind of X-shaped beams, they kind of make the whole thing look like it was designed by some structural engineer. And how we're gonna do that? Well, we will use the same trick as we did with these guys, with the support structures going from the center. But this time, instead of using the origin as a second point of the line, we will use the same point by index we are using from the main structure. It sounds a bit complicated, so I'm sorry about my poor explaining this stuff. So what we're gonna need is we need this circle that we already have the main structure, and we need the scaled version of it that matches the radius of the smaller one. So we're gonna create it here. We have this guy, and we're gonna use transform geometry, plug it here, and basically use the same. Where was it? I think here. Yes, we will use the same value. So we can actually do this like that. G, and we can plug it here into the scale. Let's make it a bit nicer. Let's move here. So we have the big circle and the small circle. And what we can do is use sample index. And we will use this geometry. The index will be index node. And we need to find the position. So we need to plug position field. So this will give for each point of the bigger circle, it will give us the position of the on the smaller circle. And we can use the same trick by instancing a line and then just adjusting its scale and rotation. Instance on points. The points are these guys. The line will be just mesh line. Let's make it 2 points and endpoints. And we can collapse it because we are not gonna change the settings. So this would be our lines, and then we will do align rotation to vector. Let's make some room. And we need a vector pointing from this point to the point on the smaller circle. And as we learned from the previous tutorials, we can just subtract 2 positions. Vector mat, subtract. No, what is this? Vector mat, subtract. We will subtract position. And this sampled position, and this is our vector. So we can plug it into vector field, and this will be our rotation. Let's see. Yeah, and it's pointing the opposite way. We can fix this by inversing this curve. It will point the right way. And the scale will be just the length of this vector. Yes. But they are flat now. But it's easy to fix. So what we can do is realize instances. And then for every even point, we will push it this way. For every even point, we will push this way, and every odd point, we will just push this way. See, I still remember how to erase. So how do we know which point is even and which one is odd? Easy. We take index and we take modulo. And if we index modulo by 2, it will give us zeros and ones. And we can do a set position. And for position, we need the width. This. Oops. Shift D. And what we can do is to move the whole thing to the right with the double of this value. So multiply by 2 and move just the odd points back also. Double this value. So let's start by this. We need to use combine XYZ. And we are moving by y-axis, so let's plug it into y and let's move it to offset. And then we do the same thing, but this time we scale the vector, this transform vector by -1 to invert it, and we use modulo for selection. Selection. Exactly what we need. And then we just scale it by y-axis into -1 and merge it. And the reason why we have this is because it was a mistake for multiplying. We don't need to multiply it. And we need to multiply it here. So now we have diagonals. See, sometimes mistakes happen and I keep it in the edit. So you can see the thinking process when you're creating setup like this. And let's merge it here. And let's see what we get. Nice. We have support structure. This will be the end of the first part. Unfortunately, I have to split it into 2 because it's getting a bit too long and I don't want you to get bored. The next part will be out, I think, in a week. So subscribe to this channel, like this video, and write a comment. And until the next time, bye bye. Thanks for watching.